Okay. Hello, everyone. I think we are live. What's up, everybody? Thank you guys so much for being here. First of all, I messed up the audio in my chemistry live stream just now, um, but I think I have it fixed. So let me know if this sounds okay. Can everybody hear me? Don't tell me what. You guys are weird. Hello, though. Thank you guys for being here. How's life? How is everybody doing? Talk to me. How has the first day of e-learning been? What have you guys been up to? There's an odd lag time between when I ask a question and when you guys hear it. So after I ask something, I'm just going to sit here awkwardly and look like this. Thank you, Nikki. I appreciate that more than you possibly could even know. That is words, kind words for everybody. A 2 to 3 page essay. That's not that bad. I mean, what do you have to write it about? It really doesn't sound that bad. You can knock out like 2 to 3 pages in like 30 minutes. Like that's. Eh, 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 eh. Oh no, my tripod just broke. Yeah. Got it. So you can't rush art into 30 minutes. So why isn't there a fight in the gulag? Well, I guess, Tiago, if you consider your art, then you're writing art, then I guess you're right. You can't rush it. It takes time. But depending on what the topic is and how much you know about the topic, you can make it go a little faster, I would think. Nikki, I'm really not honestly sure if you know why there isn't a fight in the Gulag or not, but I'm assuming that the Gulag reference was the new, like, Modern Warfare Fortnite version, where if you die, you can duke it out in the prison and come back to life. I think that's what the reference being made was, but I'm not exactly sure. And a few of you guys said that the first day has been boring, and I get that. I know this is boring. I said some things to my. It's always hard to like be serious twice in a row, and there's a little bit of awkwardness, of course, because I can't see you guys. So Nikki, so there will not be fighting in the gulag because I don't play Call of Duty. I haven't played Call of Duty since like the original Xbox, where I don't even know if you guys like know what that is. I actually, it's not even. I don't even have one in my house here. I have one at my dad's still, but yeah, I don't play. I don't play. No, before the 360, like the original Xbox. Look, Google it. You look it up. Um, that was the last system I played Call of Duty on. So maybe I should come back to it. I know a lot has changed back then, but I know. Okay, so you guys were saying, oh, it's boring. Let's see. I don't know if that's a little bit better on sound or worse on sound. Tell me which way was better. This way, louder or worse? I don't know. I'm just going to leave it. And if you guys complain about it, then I'll fix it. But if there's no complaints, then I'm going to assume that everything is good. And just to make sure that I'm actually using the correct microphone this time, because I found out that I was using the wrong microphone in the last stream. If I do, oh gosh, I almost did that again. If I do this, my voice should be gone. So that's what I'm asking. Like, can you guys still hear me, or am I gone? Is there any change that was made? Okay, perfect. Okay, great. That's exactly what I wanted to know. So that means that I am at least using things, have things set up correctly now, because like I said, during the last stream, I made a mistake. So I am at least glad that I have it fixed this time. So yay for that. Okay, so anyway, as far as Barry sent you here, well, I'm glad that you're here. I'm glad that everybody is here. It's good to be with you guys, even though I can't see you. I would have loved to do like some sort of Zoom conference or something like that. But the thing with the video chatting, if we were all on there at once, I honestly don't think it would work very well. I don't know. Maybe we'll try it. We've got a couple weeks here to try different things and see how it goes. So we'll give it a chance. But I wanted to say, okay, so I asked you guys how life was, and a few of you said it was boring, and I wanted to get back to that for a second before I got too sidetracked. I know it's boring. I understand that. It's a sacrifice. You have to view it right now, not as, oh, I'm not worried about getting sick because it doesn't seem to be too bad for young people, or oh, I am worried about getting sick. I just don't want to catch it. Really, the right mindset to have, guys, is to say, how do I stop myself from giving this to somebody else? The mindset you should have is, I already have this. I might not even know it, but I have it right now. How do I stop it from giving it to somebody else? I know that it's boring and it really stinks to be cooped up like this. It's a sacrifice, right? It's difficult, but if you think about why we're doing this to try and protect the parents, the grandparents, people who do get hurt by this disease. These have been our protectors, right? These have been our guardians. These have been people who have been there for us, who have raised us, who have kept us alive to this point. And in our generation, in our lifetimes, we've never really had to make any big sacrifices. You know, you might currently have family members who are active military, or if your grandparents were the right ages, it's very possible that they went and fought in wars for you. This is a small sacrifice in the grand scheme of things. If you look at the big picture of humanity and what we've been through in history, this is a small sacrifice for us to be making. I know it's boring. The sooner we take it seriously, the sooner it will be over. So I'm sure you guys have heard that some people are saying this could last well into the summer, July or August. That might be true on a global or on a national scale. But if we take things seriously in Illinois, life will start going back to normal before that. This might take a few weeks in Illinois if everybody takes it really seriously. And then things will slowly start going back to normal. That won't be true in the whole country. So in the country as a whole, this could take a while. Yeah. But we're getting ahead of things here in this state. And so if we take this seriously now, it's going to be over sooner. That's really important. Graduation on Google Classroom. Well, somebody asked me about prom, right? Prom is in May. It's very possible that prom will still happen. It's possible. It's going to take, yeah, no, no prom on Club Penguin. I'm going to be a hard no on that. It's very possible, though, that if everyone in the state takes this seriously, life will be back to normal enough for prom to still happen. It's possible. I can't say anything for sure. I don't know that, all right? But if we get ahead of this, flatten that curve I'm sure you guys have heard about, then we're going to get through it. Quarantined and they're going to announce it soon. Well, you know, Lily, like that's possible. What you're seeing right now happen in California is they've said shelter in place. It means that though they are still allowed to go outside, you're allowed to go outside and take a walk. as long as you're not with people that you normally wouldn't be associating with, or like your family. You're allowed to go outside and take a walk as long as it's with people who live inside your household. You are allowed to go to the grocery store for groceries, but it's one person per family. Go out to the grocery store and then come home. So even if we do go under some kind of quarantine like that, you are still going to be able to go out and get essential supplies. But yeah, you're not going to be able to be, going out and socializing. And as far as taking care of your health, it's a great time to exercise. You can exercise indoors. You don't have to go to the gym. You don't have to sit around all day eating junk food. Try and your best to like make a routine for your life. Yeah, you're not going to be going to the gym. Here's what I would recommend. Here's one thing you guys really need to do. One thing you guys really need to do is hit do not disturb on this thing. So I'm trying to clear all my notifications, even though honestly, I guess there's really nothing on here that I don't want you guys seeing. So that's no big deal. But do not disturb or turn this off. Disconnect from this thing for a little bit of time each day. I just got a question. My wife just asked if we need a visit from a special guest. So I'm going to bring a special guest down. Not her. That would be not that exciting. Oh, don't tell her I said that. Okay. So as I was saying, right, get off social media for a little while. Disconnect for a little while. If you do that, oh no, who's the pupper? Momo, come here. Oh, hello. Hello, puppy. Kisses. Oh, yes. Hello. Hi. Who's a good boy? Who's a good boy? It's not the baby. I'm sorry, everybody. The baby is taking a nap, but we'll reschedule this and I'll show you the baby at some point in the next couple of weeks. Huh? She might be up in a few minutes, so she can come. It is a nice chicken, right? I know. He's a good dog. Give me kisses. Oh, good boy. Okay. All right. Bye, dog. Come on. Good boy, Mo. All right. So what was I saying? Yeah. So, and do what? What happens without social media, right? I know. It's a scary question. Check it out. It's possible. It's possible. Here's what's going to happen if you try and get away from your social network for a little while. At first, you might feel a little lonely because that's your way of connecting. But what you should still be doing is calling your friends. You can still FaceTime with your friends. You can still communicate with the people who are closest to you, who matter most to you. Here's what I'm asking you guys to do, right? You've got 3 weeks here. I mean, one of those weeks is spring break, but we might still supposed to be cooped up for spring break too. And I know that's sad, but take this opportunity and try something out. Because who knows? You don't know what the results will be. But what if you, for a couple of days, either completely cut off or super reduced how much time you spend on social media? Like I said, at first it's going to be loneliness because that's your way of connecting with the world and with each other. But once you get over that initial loneliness, what you're going to start to realize is who the people in your life that matter most to you are. Because you're still going to text your friends or Snapchat them, I guess. But try and, I don't know, Snapchat's the worst. That's just me being old. Whatever, Snapchat them. I don't care. You're still going to have contact with your friends, right? You're still going to have contact with the people who matter most to you. And you're going to learn who matters most to you in your life. And that can be a very valuable thing to figure out. So I would just say to, what is scripted? I don't even understand what that means. I don't get it. David, explain what you mean by that. I'm being serious right now. I'm trying to be genuine, at least. I want you guys to try it. Thanks, everybody. You always know just how to make me feel good. You always know just how to warm my heart up, everybody. I really, So your words of encouragement are, something that I look forward to every single day. Yeah. So let's talk about physics. Hey, listen, guys, I'm trying to be serious about something. Like, this is not going to be easy. Like, I know I got 10 likes on this one, and I don't think there's any dislikes yet. So, like, I'm feeling really good about that, actually. Yeah. I know the dislikes are going to come in soon, so I'm not too worried about the ratios or anything like that. But no, we can start learning some physics now. And I'm trying to be. Oh, all right. All right. Thank you, David. I appreciate that. Um, so anyway, guys. Oh, we're up to. There's a dislike. Come on, bring on those dislikes. Get them going, everybody. Get them going. No, listen, seriously. Um, I know that maybe you don't want to hear this right now. I'm not trying to preach. I didn't write anything down. I'm speaking from the heart right now. I know this is going to be hard, okay? And I'm trying to yeah, no, there's no super chat donation. Although that would be awesome. I would love to be able to accept those, but no. I'm trying to just tell you guys that I know this is going to be challenging, right? And there are things that you can do that are going to help. And disconnecting from social media for a little bit each day and just learning to appreciate what you do have and the family that you have around you and who your true friends are in this life is going to help you get through this. But the other thing that I wanted to say, and then we're going to start with some physics and then we'll be done, is that if you are in need of anything right now, if you are in need of anything academically, emotionally, practically, physically, like if you need supplies, if you need certain things, as everyone now in the chat will say, toilet paper. I really don't understand what the need for 200 rolls of toilet paper for 2 weeks of quarantine are. If you're going through that much toilet paper, you have problems. But no, seriously, if you guys are in need of literally anything at all, please reach out and ask anyone at Fenton, myself, anyone else in the building. We are here for you guys to help you get through this. I know it's not going to be easy. It's something that none of us have ever lived through in our lifetimes, but we will get through it together. That's the most important thing. As a community, as a family, we are going to be getting through this together. And so, yeah, the act of God thing, you brought that up earlier, and I forgot to mention it. Here's the thing. I know this might not be what you guys want to hear, and you're probably not going to like the way that I'm going to present this or say this to you, but you deserve to keep learning. Okay? I know you're probably going to say to me, like, hey, here, don't tell me what I deserve. I deserve a 3-week vacation. Well, here's the thing, like, that vacation could be 3 weeks, best case scenario. It could be longer than that. We don't really know. And you guys deserve the opportunity to keep learning. Your education is important, it matters. This is not like an end point in anybody's life. This is a blip in the middle. And life is going to keep going on after this is over. And you have to be ready for life to keep going on after this is over. And that means that you have to keep learning because there are steps after this. So, as far as what I'm going to do, I'm going to try and keep teaching. There aren't going to be any graded assessments. So, right, that's a great point. AP tests are still going to be happening. You're going to be going off to college next year, or you're going to be having your senior year of high school next year. Like, I know it doesn't, I know somebody telling you what you deserve is a weird way to think about things, but if you can trust me on this, you deserve the right and the opportunity to continue to learn. And think about it like this, you're already telling me that this is boring. Think of how boring it would be if you didn't have anything to do. I I love video games. I really do. There's only so many hours I can spend in a day playing video games for days and weeks at a time before I start to feel pretty crappy. And I know that when I was a high schooler, I could spend a lot more time playing video games, Like as I've gotten older, the amount of time that I can devote till I start to feel has gone down. So I know it's longer for you guys as far as how much time you can devote to it before starting to feel bad, but it will happen. So I know, like, why are we not just canceling school entirely? Because you deserve to keep learning. Because the alternative is a boredom that's even worse than what you are already experiencing. And because life is going to go on after this. Like, you have to be prepared for that life when it happens. Things are going to go back to normal, hopefully soon, but they're going to go back to normal eventually. So you have to be ready for that, and AP testing included, and all those things. But what am I going to do in response to everything that's going on? It's still not clear what Fenton and the school district is going to decide or guide their teachers in doing. But my personal stance on it is this: I'm going to keep giving you guys quizzes, assessments, things for you to do to check how are you progressing? Are you learning? Are you making progress? They're not going to be graded in Power School in any way that's going to affect your GPA. But we're going to be back this year. We're still going to have a final exam. Like, we're still going to hold you accountable for the things that you are going to learn in second semester physics. So what we learned during e-learning is going to be content that you're going to be responsible for knowing by the end of the year. And obviously, we'll review when we get to see each other in person again, which is going to happen, okay? But in the meantime, we've got to keep learning. And so there's not going to be anything graded in Power School that I give to you, but I am going to give you quizzes just as a way to see, are you still making progress? And that's really important. Give your brain something to do, and you're going to feel less bored, and this time is going to go by faster. Give your brain nothing to do, and this is going to be a very, very long couple of weeks. So, John, that's my explanation for why I feel like we need to try and keep learning. That's how I'm going to be handling grades. I'm not going to be giving them, but I am going to be giving assessments so that you guys can see if you're making progress. So how does everybody feel about that? Are we ready to start a little bit of physics? Do you guys have any other questions or anything else that you want to talk about? Anything else you want to get off your chest? Anything else that I can answer? Otherwise, we're going to talk a little bit of physics. So I'll give you guys a second while I pull up the circuit that I put on Google Classroom yesterday. All right, so no one has said anything. So let's start a little physics. What you guys will need is a calculator. If you don't have a calculator, just type calculator into Google and you'll be set. It's right there. You got this. You guys should be having a notebook, like do a little bit of writing to write and take some notes down. And that's really it. I'm going to go through the circuit that I put on Google Classroom yesterday, and we're going to talk about it. It's a complex circuit, and we'll talk about how to solve it and the strategy for solving it. And then I'll answer any questions. I'll tell you guys what we're going to be doing tomorrow, and we'll leave it from there. So since the chat is quiet, I'm going to assume that everybody's ready. Here's the circuit that I put on Google Classroom yesterday. We've got a battery that was 6 volts. And then that's connected to, oh, you know what? Let me make some space so that I still have room to put the actual data table. That came down and we had 2 parallel branches. One had a 9 ohm resistor on it. Let's call that R1. And then one had a 1 ohm resistor and a 5 ohm resistor. So we'll call that R2 and R3. and then they went back to the battery. So that's the circuit that I had online yesterday. If we make our data table, we need V, I, and R. And so we've got R1, R2, R3, and we'll have our total kind of values just so we can talk about what those should be. We know that our voltage is 6 volts. That's our total voltage. We know that our resistances are 9 ohms. We know R2, what I've said is that's the one that's 1 ohm, and then R3 is the one that is 5 ohms. All right, so are there any questions so far? Can you guys see this okay? Like I said, can't see you guys, can't hear you guys, so the only way for me to know if you're ready for the next step is if you communicate it in the chat room. So, are you guys ready for the next step? And our goal is going to be, thank you, Diego. So our goal is going to be to solve the rest of this circuit to fill in the blanks here. And we're going to have to use some of our circuit rules to do that. So we have a complex circuit. This parallel branch, we need, first of all, we've got R1 there, that's fine. But where we have R2 and R3, we need to combine those into a single equivalent circuit that I'll call R23. And then we can go back up and solve that. So we need to first combine R2 and R3. Well, that's really simple here because they're two resistors that are in series together. So how does the resistance, what is the equivalent resistance if I have two things that are in series, right? I've got a 1 ohm resistor and a 5 ohm resistor. If I pretended that they were combined into a single thing, that would have a resistance of 6 ohms. Because they're resistors in series, all I have to do is add those two resistances together. So now I've got R1, which is a resistor that's in parallel with this imaginary resistor 2, 3 that I've added. And R1 has a resistance of 9 ohms. Okay, well, now that I have that figured out, I've got two resistors that are in parallel together. So what is the total resistance of R1 and the combined imaginary resistor R23? Because they're in parallel, I can't just add the resistances together, so the answer is not 15 ohms. I have to use the parallel resistors rule. So I'm going to say that that resistance is equal to the inverse of the first resistor, 9 ohms, plus the inverse of the second resistor, which is the 6 ohm imaginary resistor that we put together, and then take the inverse of that. So if you punch that into your calculator, ta-da, 9 inverse plus 6 inverse, take the inverse. I don't know if you guys can see that. Not super well, but 3.6 ohms is our total overall resistance for this circuit. We were able to figure that out by first combining R2 and R3 into one equivalent resistor. And then we're going to say, okay, now I've got just two resistors in parallel with each other. So I took something that was complex, a complex circuit, and I simplified it so that it was just a basic parallel circuit. That's the strategy for all complex circuits. You first have to simplify them so that they are either just a basic series circuit or so that they are just a basic parallel circuit. So that's exactly what we did. This was complex because it was series and parallel combined. We took the series, we combined them together so that we had a basic parallel circuit that we were then able to solve. Now that we have that figured out, we can start to go through and talk about the rest of this. So first of all, we can figure the overall current of the circuit. So 6 divided by 3.6, because V equals I divided by R, right, is 1 2/3. So the overall current of the circuit is 1 2/3. That's what's coming out That's the I out. That's my 1 2/3 amps coming out of the circuit. I was able to figure that out using Ohm's law. Now, how are we going to talk about what happens when it splits? That current is going to get divided as it goes through that junction. And I don't know how much of it is going to go through branch 1, where resistor 1 is, and branch 2, where resistors 2 and 3 are. It's not going to be evenly split because the resistances of these two branches are not evenly split. So, what do, right? I want to give you guys a second to think about that. There is a way we could possibly solve this because we know the resistances of each of the branches, but there's an easier way that's got nothing at all to do with current or resistance for that matter. What do we know about the voltage through those two branches? Tell me in the comments, guys. What can you say is true about the voltage through the top branch and the voltage through the bottom branch? Paul says that the voltage through both branches is the same. Nikki asked, how did I get the total current? So to answer Nikki's question, I got the total resistance first. So then once I had the total resistance, Nick, and the way I got that was by this stuff in the blue down here. I took R2, 3 and combined them into a single resistor, which has a resistance of 6 because 2 is 1 ohm and 3 is 5 ohms. Then I said these are two resistances now that are in parallel with each other. Basically, I took my whole circuit and simplified it down to this one little part that I've drawn in blue. And then I use the inverse, because these are resistors in parallel, I have to use the parallel resistor formula. So that's the inverse of those two resistances to get the total resistance. Once I have the total resistance, Nikki, V equals I times R. So V divided by R equals I. And so I just did 6 divided by 3.6 to get that current. So Nikki, let me know if that answered your question. And Paul, Diego, and David, you guys are all correct. The voltage through each of these branches is going to be the same because remember, I've got 6 volts of energy here. No matter which path through the circuit I take, I have to use up 6 volts. So whether I go through the top branch or whether I go through the bottom branch, 6 volts has to be used. So that means that resistor 1 will have a voltage of 6 volts across it. Because imagine this, if you were a single electron going through this circuit and you went through resistor 1, is there anything else in the circuit that would use up energy after you went through R1? You go through R1, you're done. There's nothing else in your path that's going to take up energy from you. So R1 has to use 6 volts of energy. Because remember, we've got to get down to 0 volts by the time we go back into the battery. For the bottom branch, are R2 and R3 both going to have 6 volts? I mean, think about that for a second. If you went through R2 and used up 6 volts, would you have any energy left for R3? And that wouldn't be physically allowed. There's always got to be something left in the bank if there's another object in the path of your circuit, right? So here's how we're going to do this. It's not 3, John, you guessed 3 because, oh, these two resistors have 6 volts to share between them, but it's not going to be shared evenly. Shoot. So what is shared evenly between these two resistors, R2 and R3? Not the voltage. They will not have an equal voltage because they don't have equal resistances. But what is going to be the same for both R2 and R3. That's exactly right, Paul. The current will be the same. Because these are both on the same series straight line path, any current that goes through R2 is also going to go through R3. So the current is going to be the same for R2 and R3. So we need to figure out what that is. How are we going to figure out what that is? Okay, so let's do this. Let's figure out how much current went through our top branch, right? How much current went through our branch up on the top? Well, check it out. We can use Ohm's law to figure that out really easily. 6 divided by 9, that's 2/3, right? So 0.66 or 0.67 amps went through the branch on top. 0.67 amps went through that top branch. If I can do math, I can. Yay. So, and the reason that is, Nikki, is because I used Ohm's law again. 6 volts divided by 9 ohms, V equals I times R. So if I want to know the current, if I want to know I, it's equal to V divided by R. So 6 divided by 9, I get 2/3 of an amp going through the branch up on the top. Well, if 2/3 of an amp went through the branch on the top, how much current is left over for the branch on the bottom? What was the total current available for our circuit? Oh, not sure yet. You'll have to let me get to that, Nick. I honestly don't know. So wait a minute. Somebody has the right answer out there. But the total current available for our circuit was 1.67 amps. That was the overall total current. I just determined that 0.67 goes through the top. So how much is left over for the bottom? 1 amp is left over for the bottom. R2 has 1 amp, and R3 has 1 amp. You put 1.36 because you didn't round correctly. All right, that's 6. We gets rounded up to, wait a minute. Huh? I don't know what that means. 1.67 is the total overall current. I'm going to pause for a second. I just want to see if everyone's okay with that, what we have. And if you're not sure where we got any of the numbers that are in our data tables so far, if you're not sure where we got any of those numbers from, please ask now. Just be specific about which value you're talking about. Just don't tell me a number. Tell me, how did you get the current for R3? You know, like, be specific so that I can answer your questions. If anyone has any questions at all about where we got this information from. So once we have that, so the 1 amp doesn't split into 0.5. Oh, okay. Right, so no. So this 1 amp, both R2 and R3 get to share it. I wish the back of my whiteboard, I wish I had a whiteboard with a back. Let me get a piece of scratch paper. Both R2 and R3 get to share that 1 amp, and that's because they are in a series together. So if you imagine you've got 1 amp coming through here, and remember, current in has to equal current out. So this is conservation of charge. Conservation of charge tells us that 1 amp goes in, 1 amp goes out. 1 amp goes in, 1 amp goes out. So as long as these are in series with each other, that 1 amp is just going to be constant through that path. It splits at this junction here because this junction is a fork where the current will split and go 2 separate ways. I'm going to answer your question, John, in a second, but I have another special guest. Who is this one? This one is not my puppy. This one is my baby. Say hi. Say hi. Hi. Hello. Happy St. Patrick's Day, everybody. I wanted to say hello. Hi, Ellie. Hi. Haha. Can you say hello? Hello. It's Baker Jr. She's not very talkative right now, but sometimes she likes to speak up a little bit more. Yeah, 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 yeah. I wonder if I can make her giggle. I don't know. Look, wait, she has a school bus. How appropriate is that? I don't know if my wife gave that to her on purpose, but that's hilarious. So happy St. Patrick's Day, everyone. I'm gonna give her back to mommy. All right, let's talk about what were we talking about next? So when the resistances are different, does that always mean the currents are the same? I know she does look like me, right? Poor girl. I feel so bad for her. So John's question, when the resistances are different, does that mean the currents are the same? The current in this case has nothing to do with the resistances. Check it out. These are two resistors that are in series with each other. The current will always be the same for them no matter what their resistances are. Because of the law of conservation of charge, current in equals current out, which is then current in, which is then current out. These resistors could be the same. These resistors could be different. It doesn't matter. Because they are in series together, they have to have the same current. This could be 72 resistors in a row, all with different resistances or all with the same resistance. Doesn't matter. They would always have to have the same current going through them because they're all in a straight line. So an electron goes into R2 and then comes out. And then that electron goes into R3 and then that electron comes out. And it's like a train. So if you imagine electrons like train cars going along from one part of the circuit to the other, you can't all of a sudden add more train cars over here and have less over here. That's not how real life works, right? So, John, I hope that answered your question. The currents are not the same for R1 and the bottom branch because it's a fork. If this was our example of a train, some of the train would fork off and go that way, and the other part of the train would fork off and go down the bottom way. So in parallel, your currents are not going to be the same for both of the branches that are in parallel, but your voltage will be because of the law of conservation of energy. The law of conservation of charge says that current is the same for things that are in series with each other. The law of conservation of energy says that voltage is the same for things that are in parallel together. Oops. And so now you might be thinking to yourself, but wait a minute, the voltage for R1 was 6 volts. And if I use Ohm's law, the voltage for R2 is 1 volt. And the voltage for R3 is 5 volts. And Baker, those are not the same as 6? Have you bamboozled me? What is this? Think about it for a second. What is the total energy that gets used if you go through the bottom branch? What is the total energy that gets used if you go through the bottom branch? R2 uses 1 volt. R3 uses 5 volts, which is a total of 6, which is what we know it has to be because we have to use 6 volts total as we go through that bottom branch. So it all works out. Lovely. Science is great. We solved this circuit. We used the laws of conservation of energy and conservation of charge to inform us of when we could assume that the voltage was the same and when we could assume that the current was the same. We had to use the basic idea of any complex circuit, which is to simplify it down into a basic series or a basic parallel. So we took our complicated circuit, which was drawn in black, and we combined R2 and R3 into their equivalent resistance resistor, R23. Because they were in series with each other, all we had to do was add their two resistances together to tell us that that equivalent resistance would be 6 ohms. What we had then done is simplified our complex circuit into a basic parallel circuit. Because it's a basic parallel circuit, we can figure out its total resistance. Honestly, though, we could have skipped that step. We could have said this right from the bat. We still would have needed to know the total resistance, though, so that we could figure out how the current would get divided, because we were able to say that, oh, because we know R1 being all by itself in the circuit has a voltage of 6 volts, using Ohm's law, it must have a current of 2/3 of an amp. And because the overall circuit has a current of 1 and 2/3 of an amp, if 2/3 got used at the top, then 1 has to be left over for the bottom. So we could fill in R2 and R3 and use Ohm's law to find the voltages for R2 and R3. We solved the circuit. So I want to ask if there's any questions left, if there's anything you guys want to talk about just related to life, to the world, to physics, to this question. For your assignment, I'm going to post another circuit in Google Classroom, and I want you guys to try and solve it for homework. And then tomorrow, we're going to go over it together on tomorrow's live stream. I might have to move the time of tomorrow's live stream. So check Google Classroom. I will make an announcement there for when tomorrow's live stream will be. I have not ruled out the possibility of streaming Rocket League. We've got a couple weeks, John. It's going to take some time. I'm also going to try and upgrade my camera setup so that I can get a little bit better camera, but I think it looks like you guys can see this okay. Barago has one at 10 a.m. tomorrow. Okay, so I will try and maybe move the time of mine. Would 2 o'clock work for everybody? I'm thinking later, not earlier. So would 2 o'clock be okay? And if that's okay with everybody, I think that's what we'll do. So I'll put all that information in Google Classroom. I'm going to put a circuit in Google Classroom that I want you guys to solve. And then tomorrow's live stream, we will talk about it. Is there anything else, any other questions you guys have about anything at all before we say goodbye? It's been great for you guys being here today. I really appreciate, Nikki, Minecraft is just going to have to wait. I don't know what we're going to do. What you should do, Nikki, here's what you should do. Somebody needs to buy a realm, because I play Minecraft on my Xbox, so I can't host my own server. If I did, I would totally host my own server. But somebody needs to buy a realm, and then we can all play Minecraft together. That would be cool. So if anybody has one, you might have to send me an invite link. Actually, no, if you did that, you'd know my gamer tag, and I don't really want you guys knowing that. So no, we're probably going to pass on that. You should subscribe to Shop Teacher D. That's hilarious. And is it holding that for review? That's weird. I don't know. Live chat, top chat. I don't know what the difference between live chat and top chat is. Some messages, such as potential spam, may not be visible. So basically, it would have... That's cool. YouTube filtered Diego's comment, subscribe to Shop Teacher D, because it didn't want him promoting Shop Teacher D when he's on my channel, because you're in my house right now. But no, that's okay. Actually, yeah, Shop Teacher D, he's got a great channel. Jellichars is really killing it on there. I think he's got some good stuff. But anyway, guys, I am going to I'm going to say goodbye for now. And who knows? Maybe we will do a class Minecraft server. Who knows? We'll do something. But thank you guys so much for being here. I will see you again tomorrow at 2 o'clock. And have a great rest of your day. Check out Google Classroom for the assignment. I'll talk to you guys soon. Goodbye, everybody. Thank you for being here. I miss you guys all. I can't wait to see you again in real life. But until now, I hope this was a good use of our time. If you have any feedback, I'm happy to hear it of ways that I could do this better. I hope everything was pretty legible and that you could see everything. So that's it, guys. Goodbye. I will talk to you all soon. And have a great rest of your day, everyone.